Okay, so we're going to go to another type of linear equation. We have two of them here. Okay, so we'll number this number 1, number 2. Okay. The question asks us to solve the system of linear equations. So, we've already learned two. So before we go on to our new method, can anyone name the first one we had learned? To solve a system of linear equations, what do we do? Graphing. We can solve them by graphing the two lines and finding the point of intersection. What's the second one we learned? Substitution. Good. Okay. And finally, the third one is what we're going to go over today, which is by elimination. We're going to go over a simple example for elimination, then we'll get into harder ones after. We have two equations here, equation 1 and equation 2. What elimination essentially is trying to get rid of one of the variables. And what we're going to be doing is we're either going to be adding the two equations, so this is equation 1 and equation 2, or we're going to be, oh, I forgot to circle that. Or we're going to be subtracting the two equations. We have to decide whether we want to add or subtract to eliminate one of the variables. Okay? So, when looking at this, the first thing that needs to happen is I need to make sure the coefficients in front of the variables are the same. So I'm going to rewrite these. I have 3x plus y equals 19, and 4x minus y equals 2. Okay? Now, looking at the coefficients, are any of the variables or any of the coefficients in front of the variables the same?
Yeah. The negative and the negative one and the positive one.
Okay, they both have 1. That's what I was looking for. You're right, the signs are different, but I wanted to know the value of the coefficient. Okay? So, for x, we have two different values. Okay? So in order to eliminate those, we'd have to do an extra step. We're going to do that in a different example. We're going to start off with an easy one. The y variable, they both have technically the same coefficient with just different signs. One is a positive one, and one is a negative one. That's going to work perfectly for what we're about to do. Okay? So what I'm going to do is I'm going to be either adding or subtracting. Now, just like when we're balancing equations, I have to figure out what is going to create a 0. So I've already plotted or figured out that these are the two with the same coefficient. So I need to figure out if I were to either add this column or subtract this column, which one would create a 0. Okay? And I'm pretty sure I already wrote it in, which is unfortunate. Okay, I wanted to ask you guys that. If I add positive y plus negative y, what am I going to get?
0.
0. I'm essentially going to get 0y, you could say. So we could say we're going to get 0y, and it could be a plus or a minus. But 0 times anything is going to be just 0. So it's going to be of no value to us. We'll keep it there anyways. So since we've already done that part of it, we also need to add the x variables. So what is 3x plus 4x? 7x. Good. And for simplicity's sake, we'll just put a plus sign. The equal signs have to come down. Remember, they separate our equation. And what is 19 plus 2? 21. Okay. So now what I've done, it's similar to what we were doing in substitution. I've now created just one equation, and we're about to find out it's only going to have one variable in it. So I added the two equations together to eliminate one of the variables. Okay? So, since that 0y is going to fall off, what are we left with as an equation? Justin? 7x equals 21. Good. Well, now this should be rather simple to solve. What do I need to do to get x by itself, Ryan?
Divided by itself.
Yep, divided by 7. We're going to divide both sides by 7. What's our value of x? 3. Okay. Now, there's two ways to go about it from here. From here, I could substitute this x value into either of the equations above. So we'll just put the entire page. I can plug it into either equation 2 for x or equation 1 and solve for y. But again, that would be using substitution again. Okay, so that would be using elimination to solve the first part and then substitution for the second. Since we're on this example, how long has this been? 4 minutes? what I'm going to do is I'm going to show you how to eliminate the other variables to solve for y. Okay, so we're going to do the exact same equation, but this time, so this is actually how to do it the harder way. Zoom in again. We're going to take these exact same examples. So again, equation 1, which is 3x plus y equals 19, and 4x minus y equals 2. Now we've already eliminated for the y's. So what I need to do now is I need to eliminate for the x variable. But the problem is my coefficients are different. So this is similar to getting equivalent fractions. I'm going to need to multiply to get a common coefficient. What would be a common coefficient of 3 and 4? Or a common multiple? 12, that's right. So what I'm going to do is I'm going to multiply my first equation to make 3 12. So what would I have to multiply 3 by to get 12? 4. So I'm going to multiply the entire equation by 4. So that's every single term in here by 4. And then for the bottom, what would I have to multiply everything by?
3.
3, good. So I need to multiply everything by 3 in order to make the x 12. So now we have two new equations. 3 times 4 is going to give us 12x. 1 times 4 is going to give us 4y. And 19 times 4 is going to give us 676. Okay. Same with the bottom equation. I'm going to have 12x minus 3y equals 6. So now I have two equations where the coefficients for the x variable are the same. Now I have to choose. Now once my coefficient is the same, do I add these to eliminate them or do I subtract them? Subtract. They're both positive terms, so in order to create a 0, I'm going to actually have to subtract, which is different from what we had to do with the other one. Okay? So we're going to subtract these two equations, and we'll go through it column by column. Right? So the first column is positive 12x, subtract positive 12x. What's that going to give me? 0x. 4y, subtract negative 3y. That's right. Okay? Because we have two negatives beside each other, this is positive 7y. Okay? Make sure you guys know that stuff. And 76 subtract 6. Anyone know? Quick? 70. Again, we've eliminated the x, so I only have one equation. So my equation essentially reads 7y is equal to 70. And we know from before to isolate that variable, we just need to divide by the coefficient, which is 7. Y equals 10. Okay? So we've now gone about solving both of these using elimination. Technically, we really need you to do it once and then substitute after, but this is the proper way to eliminate throughout the entire equation.